The difference between a simple machine and an intelligent robot comes down to one thing: its ability to make decisions. Understanding how to make robots think is what allows your robot to be truly autonomous and react to a changing game field. In this video, I'm going to show you the fundamental tool for creating that intelligence in your FTC robot using Java. My name is Coach Pratt, and for over a decade, I've taught robotics and design. I've coached FTC teams to national and world stages, winning national championships, and multiple Inspire Awards. I've seen that a solid grasp of these core programming concepts is what separates good teams from championship-winning teams. So today, I'm going to walk you through selection statements, step by step. We'll start with the basic if statement, build on that with what an else is, and then expand to handle multiple choices using if, else statements, and what that all means. And I'll show you some more complex logic by using and, or, and not operators, all with some practical examples you can start using right away on your own robot. So let's go ahead and jump right into this. The first thing we're going to do is we're going to create a new class. And we're going to call this class if practice. So in programming, you have something called a conditional statement. If you remember, robots are sensing, thinking, acting machines. And up to this point, we've talked a little bit about the sensing by using that gamepad. But we haven't done any thinking with our robot. And an if statement is really that basic building block for how you can make a robot think. For example, if it's raining, you should use an umbrella. Or if it's hot out, you should put on some shorts or a dress so that you can cool yourself down. The if statement is the basic building block for any program. And it's really the starting of our thinking machine. So we're going to make a public class. It's going to be if practice. And as always, we're going to extend the op mode. Before this, we're going to write that little @ symbol to put in teleop, because if we don't put that in, there's no way for us to actually access this on our driver station or autonomous. Inside of our op mode, we always need two methods. We need that init method and we need that loop. So I'm going to go ahead and do our public void init. We're not going to put anything in the initialization statement this time. Instead, we're going to put everything inside the public void loop. And the first thing we're going to do is we are going to read our game stick button. It's going to be a new Boolean. So we're going to say Boolean a button is equal to gamepad1.a. So if you remember, with this game button, with the gamepad, if we press, it returns true, and depressed is false. So let's get into our first if statement. I'm going to write the word if, and then inside parentheses, we can write a condition. So in this case, we can say if a button, and then curly brackets for our if statement. So if a button. Now that doesn't make a lot of sense originally. But you have to remember back to what a Boolean means. And a Boolean returns true or false. So if we're not pressing the button, we know that this is going to say false. If we are pressing the button, it's going to say true. Because the value of a button is true or false. And we only ever run true statements. So we'll say that if the A button is true, then we could do something with that. Let's say telemetry.addData. And we're going to add the data, A button, comma, pressed with the semicolon. Then we can simply, after our if statement, we're going to say telemetry.addData, and we're going to add in the A button state. And we'll just simply put in a button with a semicolon. If we look at our whole program, I realize I've forgotten a curly bracket here. Thank you, rainbow brackets. If we look at our whole program, we have nothing in the initialize statement. Then inside of our loop, we're simply going to read the A button. If the A button is pressed, we're going to add some telemetry that says pressed. Otherwise, we're going to go directly into the A button state. So let's go ahead and test this out. So we're going to make sure that our Rev Control Hub is hooked up. We're going to make sure that We are using a USB-C to USB-A cable to be able to connect this to our control hub. So remember, you cannot use a C to C cable. Back to our IDE here, we can go ahead and click this little run in order to compile our code and install it onto our robot controller. And let's see what this does. While this is getting set up, this is a good time to have our gamepad recognize, or the driver station recognize the gamepad, because presently we haven't set that up. If you have reset your driver station, you need to set the back. So I'm going to hold start and press the A button for user 1 to show up. If I were to have user 2, I would hold start and the B button. So now that it has fully loaded and compiled, we're going to open up TeleOp, go to our if practice. We'll go to init. You notice nothing shows up in our loop. We currently have A button is false. Watch what happens when I push the A button. So if I push it, you'll notice that if statement now shows up as true. A button is pressed. And when I let go, that statement disappears. As I press it again, it shows up. As I let go, it disappears. There's also another piece of thinking logic. On top of an if statement, you could also have an else statement. So if I have my if statement here, which is A button, I can write the word else with a curly bracket. I can say telemetry.addData, and we can say our A button, or a comma. Now we have to think, you can probably guess what it is you should actually write here. In this case, we're going to write not pressed. Let's talk about that logic a little bit. If has this statement block here. Else is this block here. Now the else is kind of like saying otherwise. And otherwise, if this statement is not true, else you should do this. So for example, if you're hungry, you should get something to eat. Else, you shouldn't go eat. Yeah? So an else statement is the reverse of our if statement here. So if this condition is not true, we're going to run this. So let's go ahead and run this. And on our driver code, we expect that if we should have 2 lines of telemetry data showing up. We should have one saying either pressed or not pressed, and then down below, it can show us the current true or false state of our button. So with our new code load up, we're going to go to if practice. We'll take a look at our initialization and then play. And now you notice that when we don't have this press, not pressed shows up. And we have A button false, but as soon as I press it, now it says A button true. So that if else statement is now running as true. If it's true, if it's not true. If it's true, else do this. We're going to go back and take a look at Alan Smith's awesome book here on Learn Java for FTC. He's got a great load chart on lots of different operators that exist inside of Java. Now, there are also lots of other ways that you can write if statements. You can have equal signs, not equal to, less than, greater than, less than or equal to, or greater than or equal to. So let's go ahead and get some practice with some of these conditional operators. Now, technically, I could write if A button equals true. This is a valid statement to write. However, if we remember, the A button is a Boolean variable. So it doesn't make any sense to say if true is equal to true or if false is equal to true, because you're never actually going to do that. Instead, when you write with Booleans, it makes far more sense to just say it has the Boolean itself. So let's go ahead and try this without a Boolean variable. So let's try this in some sort of comparative value. So we'll practice with the joystick. We're going to write a quick program that tells us if the Y joystick is currently negative or it's not negative. So we are going to grab a new double, and we're going to say a double for the left Y is going to be equal to gamepad1.leftStickY. And that's just getting current reading. Then we'll make an if statement. We'll say if parentheses left Y is less than or equal to, and we'll say 0. And actually, we'll just say if left Y is less than 0. It doesn't make sense to say less than or equal to at this point. Curly bracket in order to open up our if statement. Then we're going to write telemetry.addData. And we're going to say left stick, comma, is negative, and close our parentheses off, and a semicolon to finish off that line. So if our left stick is less than 0, we should say is negative. else. Now, on an else statement, you cannot write a comparator statement. So you could not write something like else left y is greater than 0, because an else statement is kind of like a catch-all. And if the if statement that's above the else statement is not true, it's going to run our else. So for our else, we just simply write our curly bracket. We say telemetry.add data, and we're going to say left stick is positive. And I need a close parentheses and semicolon. So let's go ahead and test this out. We're going to go ahead and click on the refresh to be able to rebuild this, recompile it, and then reinstall it back onto our robot controller. And now what we'd expect is if we move the left joystick up, we should say is negative. If we pull the left joystick back, it should say is positive as long as we're below a certain value. It's just going to toggle between those two. You may also find it helpful to, at the end of your loop, to just add the current data, which would be something like left stick value, and then you can add left y, so that you can keep track of what your current left y reading is. So let's go ahead and take a look at what this looks like. So now if I were to run my program again, init and run, notice I have is positive, as I push up is negative, and as I pull back is positive. Now, the cool thing about making decisions is most robots don't typically just have two options they can do. They typically have multiple options and multiple things that they're checking for. So for instance, if it's raining, open an umbrella. Else, if it's raining, put on a jacket. Else, don't wear a jacket or an umbrella. Yeah. So there's another way that we can do this. So it's using something called an else if statement. And this is the same thing for an if, but allows us to make a chain of things. So we could say if left y is less than 0, we can add in this negative. Else if left y is greater than 0, with our curly bracket, we can have telemetry.add data. We can say left stick is greater than 0. So now we actually have 3 discrete outputs for our loops. Let's go ahead and run this, and while it's compiling, we'll talk about it. So if our left y is less than 0, we know we have a negative number. If our else if our left y is greater than 0, we know that it's greater than 0. Else, it's going to be a positive number. And perhaps at this point, we could probably write something like is 0. And that's probably a little bit more accurate as we run this. Because yes, technically it was still positive, but we can get a little bit more exact in that. So let's go ahead and take a look at our driver hub code's compiled. So we'll go ahead and open up Telia. Grab our if practice, initialize it, and then loop method. Now our stick is positive and the stick value is 0. As I move it backwards, it becomes negative, and then it comes positive. And then as I go greater, it becomes greater than 0. You can also chain as many else if statements as you want. So I can have if left y is greater than 0, else if left y is greater than 0, else if left y, forgot to do a parentheses, left y is greater than 0.5. You can say telemetry.add data. We'll say left stick greater than 50% and semicolon. Let's go ahead and compile this. Now, this is not going to work. The reason being, in an if, else statement or chain of these if and else if statements, the first true statement runs and it ignores all of the other statements. So in this case, we have else if left y is greater than 0. Then we have else if left y is greater than 0.5. If our value of left y is equal to 1, this is going to be a true statement, which means that this is going to run. This will never run, and anything below it will never run because the previous one was true. And we can verify that by looking at our drive station. And then so we're going to run our if practice, and we'll notice that as we stick value 0, as we pull it backwards, get negatives, push it forward is greater than 0. But it never will run that other else if statement. It will only ever show greater than 0, despite being in that half range. Because, and Android Studio is smart enough to let us know, it's always going to be false. Yeah. So we can grab this, pull it up. We'll just Command X to cut it out and paste it above that. Now we can check if it's greater than 0, if it's really big, or if it's just kind of big. And then we can have it check for an absolute 0. So if we were to run this, now this will actually end up correct. So you can have as many else if statements as you want. You just got to keep in mind, you don't want to add 30, 50, 100, because that's just going to make your code really difficult to parse through. Another thing you can do with if statements is something called combinations. So inside of our combinations, it allows us to check for multiple conditions at once. So you can say, if it is sunny and greater than 30 degrees, you should put on sunscreen. So we can actually have multiple ifs, multiple conditions that have to be true in order for an if statement to parse. Now, there are 3 really common ones that we use in FTC here. There are more conditions that exist in Java, but we're only going to talk about a few today. So an AND statement looks like this. It is 2 AND symbols in Java. An OR statement is 2 pipes beside each other. And a NOT statement is an exclamation mark in front of your statement. So example of a AND statement, you might say if left y is less than 0.5 and left y is greater than 0, you can check the within the band. OR statement might be something like if left y is less than 0, or we'll put in 2 pipes, or right y is less than 0. Parentheses. Now, a NOT statement might be a little bit different, where we're going to say if, parentheses, not claw closed, close parentheses, because you need to have your NOT inside of your close statement. So let's get a practical example of using a if statement. So a really common thing that happens inside programming is you might want to have some sort of dead zone inside of your code. So if you were to tap that joystick, you know you're always in the exact middle. And you don't want to be able to just tap it just a little bit in order for your robot to actually go. So let's go ahead and make one of those. So I'm going to go ahead and delete any of these if statements we have. So we're just left with our left y and with our telemetry for adding data. So I'm going to say if, parentheses, left y is less than 0.1 and left y is greater than negative 0.1, we're going to open up parentheses. We're going to write telemetry.addData, and we're going to say left stick, comma, in dead zone. So basically we're in a dead zone in the middle if we're within that range. So now if we were to run this and compile it, we have an if statement that has 2 conditions that I have to check, which means both of these conditions have to be true in order for us to be able to run this in dead zone section. So let's head on over to our driver. So let's grab our teleop, our if practice, initialization, and main loop. Now I notice that the left stick is in the dead zone. If I move it just a little bit, it still stays within that dead zone. So you notice that I can change that value to below anything of 0.1, and we can see that it's actually returning those. But as soon as I get out of that dead zone, it now responds that it's no longer in the dead zone. So let's go ahead and get in some practical exercises. First one is we're going to make a turbo button. So if the A button is not pressed, multiply the motor speed by 0.5. Otherwise, use the standard speed. In order to do this, we're going to make our left Y. We're going to rename this one to motor speed. And we're just going to remove this if statement because you don't need it. And then we're just going to add in the motor speed here. So what you need to do is if the A button is not pressed, you should multiply motor speed by 0.5. So how might you use an if statement to be able to do that? So in order to solve this one, we might just say something as simple as if, parentheses, not gamepad1.a, and then open up a curly brackets. We can take our motor speed and we can say multiplies equals to 0.5, close. Now, if you remember, this multiplied equals to is the exact same thing as writing motor speed is equal to motor speed times 0.5. I just use this one here because it's a self-referential statement and it's a lot faster than having to write down the other option. I hope you found these tutorials helpful today on working through an if and else statements. This is your bread and butter as a programmer for making your robot sense, think, and act, or actually actuate those motors. If you ran into any problems or something wasn't clear, let me know in the comments down below and I'll do my best to help you out with that. Otherwise, best of luck on your next robotics project and good luck out there this season.